Respectful greetings to everyone. Myself Shritaja. Today I am here to present my work, that is machine learning approach for stage-wise classification of Alzheimer's disease. Before stepping into the presentation, I would like to clear the difference between Alzheimer's and dementia. Alzheimer's is a specific brain disease that accounts for 60 to 80% of dementia cases, whereas dementia is a general term for the symptoms like memory loss and other reasoning and thinking skills. These are the list of the contents that I am going to explain in today's presentation. Abstract. Alois Alzheimer, a German physician, diagnosed the first case of Alzheimer's disease in early 20th century. So basically this disease is named after him. Alzheimer's disease is a progressive brain disorder that causes brain cells to waste away, that is to degenerate and also die. The most common cause of dementia is Alzheimer's disease, as I said you before, the difference between Alzheimer's and dementia. The main cause of Alzheimer's disease is abnormal buildup of proteins in and around the brain cells. The two proteins involved in this case are amyloid and tau. Memory loss will be the key symptom for the Alzheimer's disease patient. Changes in personalities will also be observed for Alzheimer's disease patient. Researchers developed many various kinds of models which predict Alzheimer's disease and also mild cognitive impairment. My work deals with stage-wise classification of Alzheimer's disease by using psychological data, that is psychological tests, and also clinical data. Literature survey. As I said you before, researchers has developed many different models, many different approaches in order to predict the Alzheimer's disease. So here are the few data types that are used by researchers. OASIS data and ADNA data are the image data, and also OASIS data is the two-type data, cross-sectional and longitudinal data, which is also converted into CSV data for research purpose. But initially these two are used as image data. So few researchers considered these two data and developed a predictive model, and whereas few psychological tests are conducted for the Alzheimer's disease patient as a survey, as a questionnaire, and also basic clinical data. So that data set is used by researchers in order to develop the model. Sensor data, where automated intelligence system is developed which observes a person behavior from the day till the night. So that is a sensor data which is collected and used for research method, and also speech data, and also single variables like brain volume, and also single psychological tests is observed and collected as single attribute for predicting the Alzheimer's disease cases. So there are few noticeable factors in all the papers that I have collected are that every researcher tends to build a model in order to predict the Alzheimer's disease. This is because as there is no cure for Alzheimer's disease, the only thing that can be done is delaying the disease progression. And also most commonly used algorithms that I have observed in this case are SVM, decision tree, random forest, and logistic regression. And also for image processing, many deep learning techniques like CNN, RCNN, hybrid CNN, SCNN, these are all used for image modeling. Problem statement. It is likely to be said that 1 among 8 people over 65 years of age are affected by Alzheimer's disease. The only thing that can be done is delaying the disease progression. So my work takes all possible psychological parameters into account and produces a predictive model for early diagnosis. This helps an Alzheimer's disease patient for getting to know which stage he or she is in and taking precautions from the beginning. Existing and proposed system. In the existing system, researchers has used different types of data and different techniques. So our case is collecting psychological data and also clinical data. So I have taken base paper into consideration as psychological test data. So in that, one technique among them is decision tree, as I said before in the conclusions of literature survey. So they have obtained around 80% accuracy. As coming to our proposed system, as our model is a multi-classifier label where there are 4 output labels that will be predicted, that is 4 stages of dementia. Basically there are 7 stages of dementia in total. So we will be considering 4 from them, and we will be developing a predictive model. So we have used the decision tree classifier, we have considered it, and optimal decision trees are considered as a hierarchy in order to increase the performance of the model. System architecture. There are total 5 modules in our system, that is dataset, exploratory data analysis, feature engineering, decision tree, classifier, that is developing a full depth decision tree, and also constructing optimal decision trees. So the output labels that are generated are non-demented, whether a person is non-demented, whether he or she is mild demented, whether he or she is moderate demented, or he or she is demented. Implementation phase. The modules in the implementation phase are: first one is library. A library in a Python is a reusable chunk. In a simple way, it is termed as collection of code modules. The second phase is exploratory data analysis. In this, we have used 3 techniques, that is univariate, bivariate, and multivariate analysis, in order to find out the patterns in the data and also the relationship between attributes. Feature engineering techniques, the third phase is. So in feature engineering techniques, we have considered only few techniques, that is imputation, outlier removal, label encoding, feature importance, feature selection, SMOT, and feature scaling. So basically feature engineering is performed on any features because to improve the performance of machine learning algorithms. So the imputation technique we have used is scan and imputed. In scan and imputed, the technique used is scan nearest neighbor techniques in order to fill the missing values. For outlier removal, we have used IQR method, interquartile range method. Outliers are detected by using box plot. For label encoding is a method where categorical data is converted into numerical data. It is an encoding technique. So next comes feature importance. Scoring will be given to particular attribute in order to know which feature is important and which is not, which is least important. Next is feature selection. Pearson correlation is performed in this stage where we have given a particular threshold value. So by using that, we have considered relevant features which are useful for building further model. SMOT, synthetic minority oversampling technique. It is an oversampling technique in order to balance the classes. We have used this in order to balance our classes as those are unbalanced initially. Next is feature scaling in order to normalize the data. The fourth phase is full depth decision tree. Here a decision tree is constructed and the obtained accuracy of the decision tree is 93.2% and the depth of the decision tree is 8. So without using any pruning or tuning techniques, simply a full depth tree is constructed initially, and later as hierarchy optimal decision trees are constructed in the next phase. So the primary goal is to develop a decision tree based on the target label. So metrics that are used in decision tree are entropy and information gain. So decision tree is a supervised machine learning algorithm that is used for both classification and regression problems. So we are in our paper, it is used as classifier as it is a classification problem. The next phase is optimal decision trees. As we all know that decision trees are prone to be overfitting. Overfitting is a problem that is generally occurred in tree-based techniques. So here tree performs very good on training data and it will perform poorly on testing data. In order to overcome this overfitting, problem, we used pruning and tuning strategies in our paper. So pruning and tuning strategies are listed here. That is, we have used cost complexity pruning, and also for hyperparameter tuning we have used random search, Bayesian optimization and genetic algorithm techniques. The hyperparameters that are tuned in our system are criterion, max features, class weight, minimum samples leave, max depth, minimal sample split, and also splitter. So the libraries that are used for above tuning techniques are sklearn, that is random search CV, grid search CV, hyperopt and Bayesian opt. Two packages are used for Bayesian optimization technique. TPOT is a library which is used for genetic algorithm. So there are multiple pruning strategies such as cost complexity pruning, minimal error pruning, reduced error pruning. So we have considered cost complexity pruning in our case. So we have obtained higher accuracy in our cost complexity pruning technique compared to the full depth tree. Hereby I conclude that AD being a health hazard, only thing that can be done is delaying the disease progression. In our work, pruned tree has shown better results compared to tuned and full depth trees. In future, we are looking forward to build UI based screening test application for predicting Alzheimer disease. Thank you.